In laser science, the parameter M2, also known as the beam quality factor, represents the degree of variation of a beam from an ideal Gaussian beam. It is calculated from the ratio of the beam parameter product, BPP, of the beam to that of a Gaussian beam with the same wavelength. It relates the beam divergence of a laser beam to the minimum focused spot size that can be achieved. For a single mode TEM00, Gaussian, laser beam, M2 is exactly 1. The M2 value for a laser beam is widely used in the laser industry as a specification, and its method of measurement is regulated as an ISO standard. M2 is useful because it reflects how well a collimated laser beam can be focused to a small spot, or how well a divergent laser source can be collimated. It is a better guide to beam quality than Gaussian appearance because there are many cases in which a beam can look Gaussian, yet have an M2 value far from unity. Likewise, a beam intensity profile can appear very un-Gaussian, yet have an M2 value close to unity. The value of M2 was determined by measuring d4 sigma or second moment width. Unlike the beam parameter product, M2 is unitless and does not vary with wavelength. Real laser beams are often non-Gaussian, being multimode or mixed mode. Multimode beam propagation is often modeled by considering a so-called embedded Gaussian, whose beam waist is m times smaller than that of the multimode beam. The diameter of the multimode beam is then m times that of the embedded Gaussian beam everywhere, and the divergence is m times greater, but the wavefront curvature is the same. The multimode beam has m2 times the beam area but 1/m2 less beam intensity than the embedded beam. This holds true for any given optical system, and thus the minimum, focused, spot size or beam waist of a multimode laser beam is m times the embedded Gaussian beam waist. The quality of a beam is important for many applications. In fiber optic communications, beams with an M2 close to 1 are required for coupling to single-mode optical fiber. M2 determines how tightly a collimated beam of a given diameter can be focused. The diameter of the focal spot varies as M2, and the irradiance scales as 1/M4. For a given laser cavity, the output beam diameter, collimated or focused, scales as M, and the irradiance is 1/M2. This is very important in laser machining and laser welding, which depend on high fluence at the weld location. Generally, M2 increases as a laser's output power increases. It is difficult to obtain excellent beam quality and high average power at the same time due to thermal lensing in the laser gain medium.